Good evening, everybody. Welcome to the end of the spring 2013 TWed Lightning Talks. Just a reminder, this is being recorded and broadcast out live via Ustream. Although I don't expect there's going to be any Q&A, just keep that in mind. Very simple rules. 3 minutes. They usually come to 2. No slides. Crib sheets are okay, but discouraged. And I'll be keeping a timer, and I'll have a bell. I'm going to go find a bell. And without further ado, here's Evan. Thanks, Robert.
So, you want to start that? I'll get through it, huh?
He wants every bit of his 3 minutes.
No, I'm just saying. So I'm Evan Patton. I'm a 4th year PhD student. This is my 7th year at RPI. I have a bachelor's and master's here as well. And my primary area of research is in reasoning about semantic web data, particularly data using ontologies written in OWL. And my primary interest is how to reason about data sets on mobile devices. And there are a number of reasons why you may want to do this. For example, it might be the case in the future that we have more health sensors or personal health information stored on phones, and you may want to build applications that can tap into the information stored there without having to take all that data, transmit it to some third-party server, and it potentially expose very critical information to people who shouldn't be allowed to see it. And so what we'd like to be able to do is to provide smart applications that could actually work with some sort of data provider on the phone that could answer questions about health data without actually having to expose all the raw data and make it available in a way that's potentially harmful to somebody's privacy. Another example would be if you wanted to take a reasoning application and deploy it in potentially a domain where there isn't a lot of direct access to power. For example, maybe you want to have some smart sensors out in the environment somewhere where they could analyze data streams coming in from their different sensors and use that to potentially recognize when there are calibration issues and automatically notify somebody, and to provide more robust logics for how to do that. And so what I'm working on right now is a reasoner that will run on mobile phones, and my goal is to examine a number of different constructs in OWL and try to determine how much they contribute to the power consumption on the phone and how distributing them across the different radios will affect power consumption, and then use that information to try to build a recommendation system that could actually help developers who want to use semantic web on the phone to make more intelligent decisions about which aspects of the ontologies to make use of. Thank you.
All right. Thank you. And what I'll do, I've got a bell. I'll ring the bell 15 seconds before.
15 minutes before?
15 minutes. What? 15 seconds before.
Oh no, I'm running it.
Yeah, one talk, one cookie.
It's a lot of cookies. Remember good? So my name is Dominic DeFranzo. I'm a 4th year CS PhD student here at TWed. My research is looking into how do we use linked data and semantic web for the social sciences. So the social sciences have a lot of interesting and very different problems that the natural sciences don't have in terms of data management, in terms of resources, in terms of philosophy, in terms of methodology and models. And I believe that linked data can still be used to help with these different issues and problems. First and foremost, one of the biggest issues that the social sciences and digital humanities have is a lot of qualitative data, something the natural sciences tends to shy away from. So trying to find different ways to represent such information, the metadata, the provenance, the different representations, the different descriptions or interpretations of such data, and using linked data technologies and different ideas, just even behind the ideas of the web, to help us out. Doing this through different projects that I'm currently working on. One is looking at very much at the qualitative side of doing large-scale social network analysis using semantic data and taking different sociological ideas and concepts and studying networks and using linked data to be able to do that. On the other side, the more qualitative side, I'm working with a bunch of cultural anthropologists and the digital repositories they keep and hold and build on for their own reports, and trying to find different ways of semantifying that information and linking that and expressing that through the Lake Open Data Cloud. And through that, I believe this link between the qualitative and quantitative, which I believe is necessary to answer a lot of the interesting sociological problems we face, can be done through linked data itself.
James.
Hello, everyone. James Michaelis, PhD student in the Cognitive Science Department here. And my interests center around, well, like many of you, this area of big data, specifically the issue of data deluge in many different domains and applications. I'm particularly interested in this notion of how users of systems that generate tons of data may enable users, human analysts with limited amounts of time to review data, these large data spaces, to decide whether or not to review certain data points in their data sets. Now, one tool, class of tools which has been developed for allowing analysts to do these massive reviews of data spaces is something known as multidimensional analysis, which allows you to break up your data spaces into sets of dimensions for enabling effective classification of data points. Now, what I'm specifically interested in with these multidimensional analysis systems is how we can incorporate details of what is known as provenance, that is, the steps by which different data points are derived in a system, into these multidimensional analysis systems. The idea behind this work is that we have to develop a means by which we can map different graphical structures of provenance, different chains of computer functions that would be applied to generating a given result to different labels in a data set, much like you'd find with, well, I guess for the logd people, you have these data sets from the US government with headers denoting different variables in the data set. One part of my work deals with mapping graphs, structures of provenance to these labels. And a second corresponding part of this work deals with enabling analysts to get back explanations of what these different labels mean with respect to the provenance they represent. Now, an important part of this work deals with how we can guide analysts to reviewing data points, the provenance of the data points, which they would be able to effectively do a detailed review of in a reasonable amount of time. So we need to develop a means by which we can cue in analysts as to what sections of the data set's provenance would be they'd be able to quickly review through these systems. Now, how am I doing on time?
You're doing great. You got 20 more seconds.
20 more seconds? Okay, I should probably not get into any specific examples, but
Okay.
all right.
Thank you, James. Great.
Hello everybody, my name is Regan. This is my second year at RPA and first year at TWC. The three people before me are talking about their research interests, but I didn't figure out a specific one. So I'd like to talk something about my topic, my project. Currently I'm doing a project called First Responder One. I've been doing this project for almost 1 year. For the last semester, when I taking the semantic e-science course from by Professor McReanis, I'm studying doing this. I built an ontology for the first responder, and we scope the problem into a very specific problem. It's called electrical qualifier, and we implement some sparkle and reasoning stuff on that, and try to figure out what kind of tool should be brought when the electrical qualifier is coming out. And this semester I'm still doing that, but we kind of switch a gear. We focus more on the social media, like we collected tweets regarding to the most recent events like Boston Marathon explosion and the Texas explosion. We're trying to figure out what people are talking about and what is the the thing that is going on, and we are seeking any methodology to help first responder community, like how better help the first responder community, and in such a way that first responder community can better help us. So that's basically it.
All right.
Thank you.
Thank you. Grab those cookies. I think they're supposed to cross their own sidewalk.
Hi, my name is Ling Fu. I'm a third-year PhD student in computer science, and I'm working on a data portal generator. And this will be a stilled version of the literature review I've just made yesterday. So I have reviewed 57 pieces of work related to data portals, and find that there are 4 aspects we can think of in terms of data portals. The first aspect is the data, and I noticed that data can be in various encodings that contains different degrees of richness in terms of semantics. So the dumbest data would be like tab separated text file, CSV, and then smarter data would be netcdf, which contains a certain kind of metadata in it. And the most smart one we know so far is the RDF encodings. So this is the first part, data. The second part is analytic functions. So most data portals would require conversions, subsetting, projections, and some real-time applications on top of the data. And the third one is the products. So after we did some analytics, we want to view the results. And the results could be from simpler to more rich. Is the simplest would be hypertextual documents. Then some static images of the visualization. And then we see some complicated animations. And lastly, the interactive visualizations. So now I know why ELDA can be so successful. The trick is that it takes the most smart data, that is RDF encoding, and generate the most simple hypertext documents. So this is like the lower corner of a cube. The smartest data and the simplest representation. And by the way, ELDA means epimorphic linked data API. So it basically enables you to generate a Java-based data portal based on Jetty servlet container without writing a single line of Java code. So that's amazing, but it actually did the trick. And the last part is the user interface. So ELDA still has some disadvantages. It basically let the user do the coding work, but more convenient tool would be command line, menu, toolbar, form, and then a wizard. So
Hi everyone, my name is Jing. I'm a CS PhD student. So today I'm just going to talk about my thesis proposal, the work I've been working on in last few terms. So the topic is how we compute semantic similarity between the entities on the web of data, using this semantic similarity computation model to develop some interesting applications. So one of the applications that I'm going to talk about today is semantic similarity-based entity matching tools. So the tools is trying to compute semantic similarity between two entities on the web of data, and based on this semantic similarity measure, it creates same as type of links between two entities. So as we know, entities on the web of data is being described by a set of triples So what we do is we compute the semantic similarity between two entities by computing the similarity between this set of triples. To compute the similarity between these triples, we leverage information theory to compute the information entropy of these triples, and then we also use machine learning approach to learn how importantly are the information described by this set of triples in terms of semantic similarity. And another problem we also solved is a scalability problem. As we know, we have a lot of data on entities on the web of data. So we adopt a very simple approach: is that if two entities mention the same keywords, then we index these entities into one block. If they don't have any keywords that are same, then we say there's no similarity between them, and we put into a different block. When we do the similarity computation, we only compute similarity between entities on the same block, so which reduce the entity pair-wise similarity computation. And then we also perform the evaluation on these two using existing benchmarks from ontology matching groups and instance matching data. It's pretty good.
Perfect.
Is that me?
That's right.
Used to be another Eric, wasn't there? Eric Amherst. I'm a PhD cognitive science student part-time, so I don't know if I'm 1 year or beyond or behind or something like that. But anyway, I'm here to celebrate arguably the 100th anniversary of the Markov chain. So arguably the first big presentation about Markov that A.A. Markov did about his probability chains was in 1913. And anyway, earlier on the semester, I was challenged by Professor Hendler to say, okay, well, this crazy idea you have about, visualizing and perceptualizing data and, collaborating with machines and all that, how are we going to come up with some way of, the machine being a collaborator? So I started looking around at sort of automated collaborators, things like chatbots and automatic music generators and algorithmic composers and things like that. And I found, lo and behold, Markov chains and these simple algorithmic structures, these probability spaces, are used. They appear throughout the literature, for music, natural language, all sorts of simulations, and so on. So I thought, well, with the tools we have now, why don't we start looking at those as a means of interactively exploring these kind of serialized data or related data, things that have more complex than just a simple, how many times does something occur? Can we actually start looking at, predicting behaviors? Like imagine, the simplest case, we look at music. If you always play the same scale, and we give you a note and say, okay, what are you likely to play next? You'll play the next note of the scale, because probabilistically, that's what we've learned through these chains. So starting to look at a lot of things. I have an example now that can do sort of some music that way, but can also can look at literature, and I fed it a couple of pages of different texts, so it kind of generate some Huck Finn or generate a little bit of Alice in Wonderland in first and second order Markov models. And the idea is eventually, I also had it listening to Twitter tweets, and it was generating its models and kind of collecting data, and then generating likely tweets and so on. So the idea is to look at more and more types of data. With those same relationships, start looking at more complex probability models as well, the AI processes, and see, okay, how can we visualize them? How can we perceptualize them? Because the systems I'm working on are meant to be used interactively. They're meant to have multimodal output and input using OSC, so you can feed it in musical things as they happen, or send it text as it happens, or control a rigging system at MPAC as it happens, and so on. So they can really kind of branch out to the outside world. And how am I doing on time?
30 seconds.
And so that's it, yeah. Kind of this multimodal, really deep visualization idea using Markov and AI kind of techniques.
Thank you.
Did you get a cookie?
Yes. One talk, one cookie. James didn't get his cookie. You're on, sir. All right. Rock and roll.
So my ultimate research objective is to be able to create a system that reasons to select and create a visualization against arbitrary data. And I think that really centers around three core problems. First is understanding the data. Second is understanding the user. And second is understanding the fundamental task that the user is trying to perform that requires the particular visualization of the particular data. And so I want to be able to do this for arbitrary data domains, so I don't want to tailor it to a particular topic. And so using the semantic web and linked data is a really good foundation to be able to work with, access, and reason about the data that are available. The problem here is that I've been gathering some evidence about the LOD cloud, and it seems that the LOD cloud has stalled, if not actually dying. This is still pretty preliminary, but the direction doesn't seem very good. And so that's a problem for me, because if I don't have a thriving linked data source, then I can't kind of exercise and develop this reasoning system to create visualizations against arbitrary data. So, and I think if that is the case, that the LOD cloud is dying, then I think the problem here is that the current approaches for producing and publishing linked data are not sustainable. And so to address that problem of sustainable linked data production, I've been working on a system that I call Prisms that is focused on production and publishing of linked data that provides repeatability, which means that the same person can reproduce the same data they already produce. It provides replicability, which means that another person can construct the same data that the original author had published. It provides a lot of provenance capture for the data that it produces, and as well as a lot of metadata using the existing best practice vocabularies and ontologies. And so what this enables is, and kind of what I'm striving to do, to fulfill here, is to be able to provide generic discoverability, which means you can actually find the data that you need, provide generic accessibility, once you find it, to actually get it so that you can just start using it, as well as overview and navigation for the data that you've been able to achieve, access and retrieve. And so really what the objective here that I'm trying to fill this gap is to try to get well-structured data to actually speak for itself, so that the data is nothing but a catalyst for the visualization that's constructed for you as a user. Thanks.
No cookie.
No, I already had 5.
He was ready to give 4 more talks.
Hi, I'm Alex Bullazell. I'm a junior here at RPI, undergraduate, dual major in computer science and IT. This semester I've been working on the Instance Hub with Dominic. I spent last summer at data.gov building an Instance Hub there, and here at RPI I've been working on kind of building like Instance Hub 2.0. The previous Instance Hub basically presents data about different kind of sets of categorically rated entities, so federal agencies, crops, toxic chemicals, United States states. So all of these are entities that are of the same category, and you present semantic information about the metadata that developers can use and can link to, and get a lot of information about these different entities. And the problem with that is it's constrained by Drupal. There's some odd constraints with the way the redirects work because of Drupal, and generally it's not the richest interface you could use to explore this data. So I've been working on moving the Instance Hub over to Loudspeaker, which is much more intuitive, much more easy to create new categories of things. Just the other day we worked on adding counties in, US counties, and it was pretty trivial to do that. Allows for more intuitive navigation and exploration. We try to make URIs that describe what they're talking about. So rather than just say, ID, like log D TWRPI / Department of Justice, we say ID US Fed Agency Department of Justice. So looking at the URI, you can understand kind of the general class of what we're talking about. Yes, we've been working on porting to Loudspeaker. We're getting it on the server. It should be on Gemini. It is on Gemini. We're working on having it up pretty shortly for actual use. Previously, just on the local machines. Thanks.
All right. Thank you.
Always come back.
I'm Josh Shinavy. I'm a fifth year PhD student in computer science. One of the things I'm working on is integrating linked data queries, linked data Sparkle queries with continuous Sparkle queries. So the idea of executing Sparkle queries over linked data is that as you're executing the Sparkle query, you pull in linked data dynamically. And as linked data documents come in, they furnish new data with which to provide new answers to the Sparkle query. So that the basic operation of a linked data query engine is that as the Sparkle query is executing, you encounter different triple patterns. The triple pattern mentions a URI. So, for example, the triple pattern might be, John Fof knows blank. Who does John know? And so, based on that, you need to look up the document that describes John. Dereference John's URI. So you fetch that document, and when it comes back, you have all the information you need to answer the query that led to that triple pattern. Well, with a continuous query, it's the same sort of situation, except instead of executing the query over a fixed cache of data, you first submit the query, and you have a stream of data coming in, and that data triggers the triple patterns to be anyway, the triple patterns are activated in exactly the same way. You fetch the documents, and then as the documents come back in, you feed the RDF data into the same stream as your source stream, and answers to the query are produced. It actually fits the event-driven model of continuous queries very well. So that's it.
Right. Thank you, Jim. All right, Jim.
Okay. Hi, I'm Jim McCusker. I'm a fourth year PhD student in computer science, and I'd like to know more about your data. We all have data that we're working with, and sometimes we even identify it. But the thing is that the data itself could be detached from that identifier. You can lose track of what that data is. It can be copied, it could be transformed, different file formats, it can be subsetted, all sorts of things that can happen to this stuff. And if what we do is come up with a set of identifiers that are inherent in the data, that you can compute from the data itself, you can actually keep those identifiers and move them along with the data. And when you do that, it actually becomes embarrassingly easy to provide provenance for that data, for how you transform it and what you do with it. And so my thesis topic surrounds the idea of providing a formalism for those sort of computable data identifiers, providing a way of explaining how you access data on the web and what the semiotics and semantics of that are, and then finally closing the loop and showing how using behavior that people like visualization specialists already do to link their visualizations to the data, we can actually provide these identifiers in a discoverable way, so that people can learn, even if they're not getting the data from the same place, whether or not they're using the same data.
That's it.
That's it.
All right. Loudly.
Hi, I'm Pastor Magni, second year PhD student in computer science. Did you ever follow someone on Twitter after you met in a conference and you liked his paper, or just because he's a well-known researcher in such domain? And after a while, all what you start receiving is how he spent his weekend, when is he walking his dog. But you cannot at the same time follow him because from time to time he tweets some important stuff. I'm sure that all we came across the situation where we keep scrolling in our Twitter timeline till we find the important stories of the day. And this is not the case only for Twitter, but for any social media. They became our main source of news and technology innovations, etc. But at the same time, finding the relevant information is a bit challenging. So today I'm talking about trusted tweets. Long story short, I'm using LinkedIn endorsements to filter trusted tweets. In details, the approach is in 4 steps. In the first step, we build the LinkedIn endorsement network. We assume that the endorsement property is transitive. So if I endorse John for Sparkle and John endorses Ryan for the same skill, I assume that I can trust Ryan tweets about Sparkle. After building this network, we get the network from Twitter, the network of followers, and we try to match the profiles from LinkedIn and Twitter. But they are not at the same level. So I may be following Tim Berners-Lee on Twitter, but not directly connected to him on LinkedIn, maybe through Professor Hender or any other person. So the matchmaking, the basic scenario is just search for names. So if I know John Erickson on Twitter and in LinkedIn, there is a high probability that they are the same person. After matchmaking these profiles, we start tracking my follower accounts on Twitter. And we annotate their tweets according to the skills vocabulary. But the tweet can be about semantic web without mentioning semantic web directly. You can mention other entities related to semantic web. Here comes the power of semantic annotations. And the skills of the vocabulary of skills will not just be a plain list of skills, but a hierarchy of skills with some properties. One interesting property that we are thinking of is the prerequisite property. For example, someone cannot know Rails without knowing Ruby, or he cannot know OI without knowing semantic web. So if I endorse him for Rails, I can trust his tweet about Ruby, but not vice versa. The same for semantic web and OI. The last step is because we have a lot of assumptions like the transitivity of the endorsement, etc., and prerequisite property, we need feedback from the user. So we give him his trusted tweets, and he will get the trusted tweet within the property, and he is allowed to tag false positives from the trusted tweet, and that's it.
All right, thank you.
Hi everyone, I'm Jifa. I'm the first year postdoc here working with Jim. My past research is mainly about social networks. So I'm currently exploring new research program integrating semantic web and social networks. So I'm currently involved of multiple projects, and the primary project is Cosmic. So besides collecting and providing high quality data to other collaborators, we are also, with the help with Josh and Basim, we extract the entities and annotations from the tweets we collected, and those annotations are linked to DBpedia, so that we can also look at the intrinsic structure of this knowledge from the data. So we are planning to produce some queries that are only possible with semantic web, not possible by the traditional table-based relational data. For example, we can get the tweets talking about certain politicians in certain cities of certain countries, something of this. So we are trying to employ the power of semantic web to do more inference on the Twitter data. And also, some of other ideas are still vague and at these early stages. For example, with these annotations extracted from the data and the structure of these annotations, we are currently having a new layer of networks so that we can have several interdependent networks besides of the social networks that has been extensively studied by other researchers. So a lot of things can be done in this topic, like the modeling of the co-evolution of the topic network and social network, and how the discussion was going on, and how people can how people can steer the composition of people through the controlling of certain layers of the network. And how many times have
We got a minute.
Okay, some of other follow-up research of my of the human flash search thing, we are conducting a survey research to seriously look at why people are willing to do those kind of crowd research on the internet, and also we are exploring new roles of people collaborating online and all kinds of this collective intelligence. And I'm also collaborating with Dominic on the data thing. So that is also multiple layers of social networks. We are looking at how those trusts transfer from certain layers of networks to another layer of social relations. So a lot of such things related to social media are all kinds of parts of my interest. So if you have any interest, any idea, just talk to me.
All right, thank you very much.
Are we ready?
We are ready.
Okay, cool. My name is Yu Chen. I'm a third-year PhD student here. And the topic I'm gonna give today is the sensor and semantic context modeling. But to be concise, it's just understand you. I mean, there's lots of research, and partly what I'm doing right now is trying to extract the patterns inside the time series in the time series data produced by your mobile sensors, such as your accelerometer, gyroscope, things like that, and try to correspond that pattern to a certain activity, such as when you're if you're walking, jumping, stepping up, and stepping down. But that's not enough, right? So, I mean, there are lots of research on that, try to learn the patterns or learn the activities from the sensors. Like, you can definitely learn that someone travels from point A to point B to point C, but without the context, we never know what they're doing. But if we try to connect the data or link the data on the web by saying point A is a set of apartments and point B is a plaza with lots of restaurants, and point C is RPI, you can definitely infer somehow that this people is a student that travels regularly from this place, and he lives in point C, and he usually has some dinner or breakfast at point B, where there's lots of restaurants. And by that, I can provide lots of information about these people. You know, there are lots of web or mobile developers that are quite interested in that, because using that, it can definitely provide some very personalized information about or personalized recommendations on these people, right? But this is really complicated because you have to deal with all those sensors and all those linked data, and that's not what the developers want to, because they have to learn a lot to really do that. So that's what I'm going to do. So I'm going to provide a web service that if he or she sent me the sensor data on the customer's mobile phone, I can probably tell the information about these people, like what's his or her hobbies, or where he lives, or what's his occupation, things like that. So it will make the mobile developers quite easy to get this information. And for now, I'm working with Josh and Han on some of the projects, and probably we'll have more publications on that. So if you are interested in it, just feel free to contact me and we'll discuss on that. Thanks.
Sounds like there should be a policy person working with them too.
So I'm Han Wang. It's my second year here as a PhD student, and I'm going to talk about the DCO on behalf of all the others working on that, including John, Yu, Marshall, and Patrick, who's probably watching us right now. So DCO stands for Deep Carbon Observatory, and our project is called DCODS, Data Science. So it's yet another data portal we're building here at TWed that integrates data management, visualization, and discovery. And so in DCO, we see everything as a first-class object. That includes like a scientist, like a researcher, a student, or a data set, or an image, or video. So basically everything is an object. We want to enable the user to be able to create a object, DCO object on our website. And when he does that, we will assign a globally unique ID to that object. And also we want to keep the metadata of the object, and hopefully we want to keep the provenance using prob of that object. And that such provenance can be, for example, data set can, for example, we have an image that is produced by a data set, and this data set is measured by some instrument. So we want to keep track of that chain. So right now we are using Vivo, which is an open source tool to use Vivo as our platform. So Vivo is pretty cool in such a way that it's built on ontology, on the semantic web technology. So hopefully we can just extend or modify the ontology without modifying any code of Vivo itself. So right now we're in a stage to hacking into Vivo and see what we can do. That's it.
Trying not to hack into Vivo, trying to learn how to use it so we don't have to hack into it. All right, go for it.
Hi everyone, my name is Xian Li. I'm a fourth year PhD in the Department of Cognitive Science. So although I'm not the last speaker of today, but I guess so far, if we try to plot a word cloud of what everyone has talked so far, I guess the biggest word is data. So yeah, I think that's true. Data is interesting, and a lot of us is not interested in collecting data, formatting data, but we are also, I think the ultimate goal that the scientific research community is trying to understand some problems or phenomena that in social science or economics or natural science from the large amounts of data we collected. I think one advantage we have been trying to claiming that we have linked data and this big data. So it's a kind of direct mean that you have more variables in the data you collected. So that means given the more variables, you should build a better model to answer certain questions. But I think in reality, you don't want to start with a very complex model with so many variables. So now I think today's talk I'm going to share some of the knowledge or experience I learned from statistical physics. It's called the non-dimensional analysis. It's trying to reduce the variables in your system, in the model you are building, to come up with a simpler model. So I think the easy example to start with. So if you have data about the such as the particle movement on a certain surface, so definitely you have data about the locations, the data at different, the particle at different points, and also you have how long it takes the particle to move from here to here. That means you have the length, you have the time, and you also have the velocity of the particle movement, and you also have other attributes of the particle itself, its mass, its shape, etc. So there's a lot of variable already. I think that what we should keep in mind is each of the variable you are collecting, you are putting your data, it has a dimension. So time has time dimension, and how long the particle has moved has the length dimension. And But some other variables, such as the velocity, the velocity dimension can be framed in terms of dimension of time and the length. And so this is the basic philosophy of such methodology. That means, so suppose you have a model with so many variables, suppose it's partial differential equation about the speed, time, and the and the length you have moved, and then you kind of divide each variable by its characteristic scales, and then using the relationship you know between the different variables, and then you kind of reduce your PDE to a simpler model. And then next you do the you plug in this simpler equation with the Taylor expansion of the variable itself, and then you keep the leading orders, and it's each iterative process. But finally, the end output is a model just with the time and the location. So the speed, the velocity variable has disappeared.
Thank you.
My name is Makoto Nakatsugi from Japanese telephony company NTT, and my current work is recommendation by using semantics as a background knowledge. And now I am interested in how to incorporate semantics theoretically to analyze user interests. And I try to apply semantics to tensor factorization method. And I'm now evaluating my method by using linked open data, freebase, and user log, music listening history. And I try to publish or convert evaluation data to linked open data and put them online, because to do so, other researchers can use those data to analyze or evaluate my method, or other researchers can enhance their methods by using such data. And I think it is interesting because combining linked open data with user log can enhance interesting applications on the web, or by using that, other researchers can enhance their researches. And however, I think there is one problem. User log sometimes include privacy information. So how to convert such user log into linked open data is a difficult problem sometimes. And I think you all have already converted such user log or social networking data to linked open data. So if you know some approach to convert those data to linked open data, please let me know. And if you are interested in my work or my research, please feel free to discuss it. Thank you.
Does anybody else want to give a talk that isn't signed up? Nobody's jumping up. I wonder why.
Like a cookie.
Yeah, do you want more cookies? Do you want a cookie? One talk, one cookie? I'm wondering, we have a couple minutes if anybody had any questions for anybody on that gave a talk. No? Everybody wants us to get out of here, huh? So in that event, this was the last TWed of the spring term. We'll probably schedule over the course of the summer. It'll be probably irregular schedule, but I think we'll try to schedule some TWed talks, probably on Wednesdays, because that's when we're trained to do that. But there's a lot of opportunity to socialize, and I want to thank everybody for your obvious hard preparation. I noticed some people who spoke may have spoken with notes in previous TWeds, gave them without notes this time, which is excellent. That's good to see. Give yourselves a round of applause. And thank you very much.